And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today is our final daily space weather video, so I don't know what to tell you, fans. We've accepted a contract, so and it's a blood pact. So I had to sign in blood, and that's just sorry. It's our final daily space weather video. Today we'll be talking about cooking. We'll give you a nice recipe, and we'll talk about a coronal mass ejection watch. Even though the chance for solar flares here at the smAsh News Network has dropped, there's still a significant possibility for coronal mass ejection. So let's take a look at these sunspots. The leading one is sunspot 2794, and the trailing group is sunspot 2795, which has degraded a little bit. Again, a perfect example of how the likelihood of solar flares has gone down due to the degradation and magnetic field situation of the sunspots, but the high likelihood for a coronal mass ejection is still there on both sides of the sun. We'll show you it and more before I vanish entirely. The 10.7 centimeter radial flux is down to 83 as solar activity has continued to diminish as those sunspots move into a setting mode in the western hemisphere of the local yellow dwarf. Here's the 1-year chart of the 10.7 centimeter radial flux. And here is sunspot number progression and 10.7 centimeter radial progression. And for you new viewers, the radial flux is a measurement of the outer solar corona, because it puts out radio frequency, and the frequency is 10.7 centimeters. Next, we're looking at a composite image here. This includes 3 different wavelengths, all in one: the 335, 193, and 94 angstroms, all combined. And if you want to check this out, folks, head to the SDO page, come up here, click on data, and use AIA/HMI browse data, and you'll have access to all of those different wavelengths. You can even rock the sun back and forth and feel like God. Look, I'm rotating the sun. Take that, local yellow dwarf. And we've got some great HelioViewer movies. By the way, if you're on HelioViewer, you can see a great view of Mercury down here in the lower left, as well as Comet Erasmus, which is, I believe it's, I can't use, never mind. It's this object up here. That's Comet Erasmus. It's not going to be on there very much longer. I'll give it another 3 days, I think, until it's out of view. Here's a 1-day video, and you can see a bunch of filamentary activity there behind sunspot 2795. There are a ton of filaments on the Earth-facing portion of the sun right now. You can see a bunch down there in the southeast corner there. Some are protruding off of the southeast limb, as well as the southwesterly limb. And we've got more HelioViewer movies, which we'll show you toward the end of the video. Next, we're going to go out to Lagrange Point 5, the location of Stereo A. But first, let me check the life of the stream. Lagrange Point 5, the location of Stereo A, to see what we can see. And what we see is a very lengthy plume of plasma out here. It's this one, as well as one on the opposite side of the sun. So as sunspot 2794 is moving into a setting mode, we've got a bunch of filaments. We do see a small coronal mass ejection coming out of this area right here. And for you new viewers, the Earth is off in this direction. This would be the ecliptic plane right here. That's the ecliptic plane, folks. And it's a small coronal mass ejection. Whether it's Earth-facing, I don't really know. I don't even really care, because it's very minor. And you can also see Venus in that image. And let's bring up the LASCO C3 here real quick to show you Comet Erasmus. So there you can see Comet Erasmus It's right up here. Lovely view of that. And again, more HelioViewer movies coming toward the end of the video. Let's do a Smash Lights segment, which will be integrated into today's daily space weather video. First of all, I'd like to invite all our viewers to head to smAsho.com. You can find all our social media links there, as well as our VoIP line, our email address, etc. Drop us a line if you like. You can also reach us at the smAsho forum, and check out the merch at the smAsho store and the Smash store. Changes coming there soon. Thanks to all of our new subscribers on YouTube. If you haven't pressed like and subscribe yet, please do so. Also, tell your local friends, your foes, your science noobs, science pros, astronomers, nerds, geeks, douchebags, morons, idiots, smart people, and those who are interested in learning about things like the sun, astrophysics, cosmology, etc. Yeah, press like and subscribe before the place burns down. That's okay, we'll wait. And as you can see, the place is on fire once again. And today, we're just going to let it burn. Yes, that's right, we're going to let it burn. Until you press like and subscribe. You could also press share. Share it on your Facebook, Twitter, wherever. We're all over social media. Thanks to our latest subscriber over at BitChute. You've put us over the 300 subscriber mark, so cheers. And if you haven't subscribed over at BitChute, please do so. There will be exclusive content. And by the way, on YouTube, we will be doing a year in review video before midnight. If you don't follow me on Twitter, you may not see top-notch recipes, such as the most recent recipe that we've put up, the Moloch burger, yes. So again, if you don't follow us and retweet our tweets, not only will Moloch consume your baby's soul, you'll miss out on exceptional recipes, like our latest burger, the Moloch burger. As we've been doing some demonic sandwiches, yes. So we did a poll, and 50% of the voters voted for the Moloch burger. So here's the recipe. The Moloch burger is a demonic sandwich consisting of 1/3 pound ritualistically slaughtered by fire human ground baby meat cooked to taste. You could also use aborted baby meat. 1 slice human Moloch cultist breast milk cheese, a sourdough bun, and human adrenal gland vinaigrette. Doesn't that sound tasty? But just kidding, folks. That's actually human adrenal gland oil and vinegar. You want to make sure that you suspend your human adrenal fluid, your adrenochrome. Make sure you suspend that in oil. Otherwise, it might degrade and lose its potency. Here at the Smash News Network, we would not want you to ruin your recipe by improperly handling the ingredients for your Moloch burger. Now let's move on, again to invite you all to head to Smasho Mash. We haven't got recipes up there yet, but it is something that could possibly happen in the future. Also, thanks to our followers over at Twitch, twitch.tv/SmashoMash, probably the world's leading streaming platform. And allow me to vanish once again before we move on here. At the Smash News Network, least busted name in news. Let's talk cosmology. Today we're not going to roll any dice. But again, head to smAshomash.com and head to the forum if you don't know anything about cosmology. We've got a whole forum about it. The Cosmology Forum. It's at smashomash.com/forum. It's free to log in if you'd like to contribute. Just head over there, click. We've got a section on a section on Cygnus X3 and all kinds of other things at smashomash.com/forum. Even one about supernovae, whether or not they destroy stars. Let's talk about stars. Our patrons are stars. That's why we list them, since they're producers of the content. Thanks to our patrons, the real source of funding for the videos. Please consider becoming a patron at the $3 or more per month tier, as the $1 and $2 tiers will be eliminated by midnight tonight. We're discontinuing those low-level tiers, partially because of inflation and partially because it's not enough cash. So, yeah, thanks to our patrons, true source of funding, patreon.com/smAshomash. Please consider funding us as we are nowhere near our 2020 goals. And what a surprise that is, as the government has been self-destructing. Let's talk about Gaminga. Gaminga is a very consistent X-ray source. You can follow its transients if you just simply head to the Neil Gorell Swift Bat X-ray Observatory. If you want to find the Gaminga pulsar, just type in Control F and then type in Gaminga and you'll find it. And these are the transient X-ray outputs of that pulsar. Now, it's a pretty interesting pulsar. It's been featured in a lot of imagery. You've probably seen images of the Gaminga, and we're going to show you images of it in a minute. I just wanted to show you this consistent X-ray output. It's kind of similar to the Crab Nebula in that it's a consistent X-ray source, consistent enough to calibrate X-ray equipment with. So here it is on Aladdin Light, and you're not going to see very much here. So we're going to bring up the Chandra, and you can see part of the jet there. Gaminga's interesting in that it only appears to have one jet. Perhaps there's a second jet that's directed directly at you, the viewer. But that's the Gaminga pulsar there in X-ray on the Chandra. And you can see the X-ray emissions from the jet protruding from one of the poloidal fields of the Gaminga pulsar. Very famous pulsar located in the Milky Way galaxy. Perhaps go have a read about Gaminga. And that's today's cosmology segment. We don't want it to be too long, as it is, after all, the daily space weather. Let's get back to data, something the SMASH News Network prides itself on, and also telling you the truth. So here is the real-time solar wind information. And we see a declining solar wind here over the past 24. Now we're down to 3.5 protons per cubic centimeter. Stay tuned for an increase in this as there is a coronal hole wind stream imminently about to strike the magnetosphere. Expect this within the next 12 hours. Current solar wind speed has also diminished down to 424 kilometers per second. The KP index has dropped down to 0. Which prompts me to show you cosmic rays. Here are the Apatity and Barentsburg neutron monitors. And you can see a downtick at Apatity over the past 30 days. At Barentsburg, also a slight downtick over the past 30 days in those two very far north monitors. Let's go farther south to the Athens, Greece neutron monitor. There you can see a similar downtick over the past 30 days at Athens. Next, we'll go even farther south to Mexico City. By the way, this one you can access archival data. There's the Mexico City cosmic ray monitor. A similar chart there over the past 30. And lastly, we'll go back farther north to the Oulu, Finland neutron monitor. And there you can see the slight downtrend over the past 30 days at Oulu. And we'll also show you DOMC Antarctica. Not DOMB, as it's been sending incomplete data. And you can see an even steeper downtick there, a downward trend at DOMC Antarctica. If you don't believe me, monitor them yourself. I like to use this site. It's got a bunch of links. Let's look at the magnetosphere. Here's the Space Weather Modeling Framework's rendition of what's going on in the magnetosphere, and you can see some variations there in the solar wind density reflected in the 4 hours of data shown here on the Geospace Magnetosphere movie. We show 4 hours of this daily, as this data is not archivally viewable. Here's what's going on the ground. We're looking at ground magnetic perturbations here since we're living through a magnetic excursion, a geomagnetic excursion, one where the South Geomagnetic Pole has left the Antarctic continent entirely and is someplace in the southern Indian Ocean there, south of Australia. And we've got two North Poles, one over both Canada and Siberia, making the net pole someplace between Greenland and Svalbard. That's 4 more hours of data. You can see magnetic pulses out of both oceans, the Atlantic and Pacific. Moving on to the proton flux, which is flatlined. And again, no major coronal mass ejections here to report on. And the X-ray flux has actually dropped here. We see a very low levels of X-ray flux. And yeah, it has to do with the degradation of the sunspots However, once again, I would note that there is a significant possibility for coronal mass ejections. It's part of the reason why we have the channel, and we'll let you know if one should show up. Next, looking at the GOES magnetometer to see pretty spiky readings here over the past 3 days, and it's no surprise there as the Earth has crossed into the other polarity current sheet. So here you can see in red the South Pole oriented current sheet into which the Earth's potential field surface source line has just moved. And that's what's created some of those sawtooth patterns on the GOES magnetometer. Expect to see continued rather wild gyrations in the GOES magnetometer as we've got some activity rising on the sun there, and even though it's not visible, there is some activity there out towards stereo A. We won't cover it on today's daily space weather video as we've got too many things to talk about. Here's a line of sight coronal hole plot, and you can see a large south pole oriented coronal hole moving into the Earth-facing zone right now, as well as a smaller North Pole oriented one. And that South Pole one is trans-equatorial. And so in about 4 or 5 days, I'll say 5 days, we can expect to see another high-speed coronal hole wind stream from that coronal hole, as there are protons blasting out of those coronal holes. Here's another view of the same thing here. It also shows you the solar magnetogram with less emphasis on the coronal hole regions. And we can see some striations happening here in the B field on the eastern limb. So you see the B field being pulled up there. And again, that's an indication of a little bit of activity out towards stereo A. Last but not least, as far as magnetic information, here is the coronal magnetic field plot. It'll show you polar potential field surface source lines in black, closed potential field surface source lines in pink, and coronal hole ones in purple. The coronal hole potential field surface source lines at the poles are the polar coronal holes, which more or less remain there all the time. I won't get into it. Next, looking at in-the-sky.org to make some forecasts. A pair of twin women will show you their butt today, or in the next few hours, as the moon travels through Gemini. Identical twins will moon you today, just before the moon passes the galactic plane, which we've drawn in here. It's that blue line. And the moon will set in Taurus. So make sure you hide your babies at that moment and don't show any images of twin women's butts to your babies at that moment. They may be consumed by Moloch. Next, looking at the solar system here, and that's where stuff is now. There's where stuff will be in a week, on the 7th day of the year of accountability, 2021. Again, don't forget to watch our year-end review video. We'll be making it later today. Let's talk electrons. We don't see any charging hazards. And once again, my forecast was exactly right. Here is the 1-year chart of the electron flux. And when you understand the physics, you can do forecasts, which is why occasionally we do meteorology as well, because I understand the physics. So here's the forecast model that we're talking about. And you can see that the observation was exactly where I forecasted it yesterday. And we're going to have to refute the forecast again, as we're going to see lower levels here over the next 2 days before rising back up. So they're actually jumping the gun a little bit with this forecast. We're going to see lower levels and then higher levels like that. That's my story, and I'm sticking to it. Here's a 3-day chart on the electron flux, and my forecast has to do with the coronal hole wind stream that's about to arrive. And we see fairly normal levels here. Actually pretty high levels at midnight. Those are actually fairly high levels for midnight, folks. Normally we see lower levels. That's midnight local time for the GOES 16, and that's noon local time for the GOES 16. Here's a visualization of the total air column. It's the total electron content forecast. That'll give you ideas of where GPS errors would be likely to be, especially around the equator at noon is typically where they are, although we see some additional electron flux blobs there over Antarctica and North America, as Greenland is part of North America. I'll let it play through a second time. And we see some electron flux anomalies there over northern Siberia as well. And here's just a diagram of the Van Allen belts and the altitudes of different spacecraft in miles. As I try not to memorize things I can look up, never memorize something you can look up. That's a quote by Einstein, by the way, who must have understood that your brain has limited space, just like a hard drive. And here's a diagram of the atmosphere here, different layers, troposphere where all your weather occurs, up to the ionosphere. And you can see the D layer there is the mesosphere, and the E layer is the thermosphere. The D, E, and F layers, those are all ionospheric layers. And the GOES 16 makes its measurements at the F layer, if that helps. Here is a visualization of just the F layer of the ionosphere, and we're seeing anomalies once again in the southern hemisphere. So we're seeing surprising charge ups of the ionosphere there in the southern hemisphere, something we typically do see during levels of low electron flux. And let's bring up the latest image, which is from 10 o'clock Universal Time, and you can see that odd electron flux region there, especially in the South Atlantic and Southern Indian Ocean. Next, we're looking at volcanoes. I'm always interested in what's erupting. Are you? VolcanoDiscovery.com certainly is. And Abico is back on the list. It's producing an 11,000-foot plume of ash. Do you understand the difference between your ash and a hole in the ground? Sakurajima is also erupting. Flight level 070, it's producing a 7,000-foot ash plume. Popocatépetl, also exploding. Flight level 200, 20,000-foot ash plume there. Fuego, Sangre, and Revenador are all exploding and producing between 16 and 20,000-foot plumes of ash. Please don't pole vault the caldera. And while we're unable to detect whether or not Sabancaya is erupting, it could be. So please do not attempt to do a handspring or the Fosbury flop over the caldera. The earthquake drought continues, folks, as we see a very, very low number of earthquakes for, indeed, years. It's a drought of 7, 8, and 9 magnitude earthquakes, statistically speaking. We do see some deep quakes, such as this 4.5 magnitude near Timor-Leste, north of Australia. It's at 417 kilometers. And we're just going to scroll up the list here as we don't see any major quakes. There's a deep one by Fiji, nearly 500 kilometers at 4.6 magnitude, which would be more like a 6 magnitude if it happened at the surface. There's another deep quake in Oceania, that one near Tonga. Another deep quake in Oceania, that one near Fiji. And what did I see there? There's one near Japan, a 4.2 magnitude at 429 kilometers depth. A 4.3 in the Aleutian Islands at depth. And on we go to look at nullschool.net. Check it out. You can actually look at the aurora. And that is a probability chart. So, probability of auroras, there you go. There's your real-time probability of auroras in the southern hemisphere, and you can see indeed how far away from the South Pole the center of that is. The South Pole is actually someplace around here, far from the Antarctic continent and from the South geographic pole. Next, we're going to look at what we usually look at daily. The jet streams. They're the jet streams of the Western world. And check it out. This extreme meridional jet stream flow is going to prompt people to say, oh my God, Greenland is melting. There's only 5 meters of snow there from coast to coast all summer long. Stop the presses and convince people of complete nonsense about carbon dioxide controlling the climate. And check out the bends over the U.S. Extreme bend there, and a low pressure trough in terms of 250 hectopascal winds. Let's take a look at the surface winds real quick. And you can see vast differences between the jet stream and the surface winds. Next, we'll look at the jet streams of the eastern world, as we don't want the video to be too long and do a meteorology segment, as this is the space weather! And there are the jet streams of the eastern world. The GOES lightning mapper is showing us some serious lightning there in southern Texas. Yowzers. And let's check out lightningmaps.org to see if there are any active strikes striking now. And indeed there are. There's a heck of a storm there to the west of San Antonio. If you're in a skyscraper, go take a look to your west and your northwest. And hey, Uvalde, there's thunder rolling in. Also Brackettville. And that's probably going to move to the northeast. Hey, Bandera, there's thunder rolling in. Convince your foes that you're Thor and that you're causing the lightning at lightningmaps.org. Next, look at the Doppler radar map, and we see a 2,500 mile line of moisture here. Precipitation going all the way from Newfoundland to El Paso, and it is snowing in West Texas. Snowing and wintry mix. We'll show you a forecast. One of the irregular features here at the Smash News Network. So now we're on Tropical Tidbits, and this is the GFS forecast through Sunday, January 3rd. So about when we make this video on Sunday, on January 3rd, it will be, that's what the GFS forecast is calling for. And it's actually an uptick here. Now forecasting over 12 inches of snow there in West Texas, as well as in Mexico. So that is that's probably some sort of record-breaking snowstorm. And you can see a large band of snow reaching all the way up into Missouri, really all the way to Lake Michigan. And we're expecting 2 inches here in the Lehigh Valley as well. If you're wondering where we're located, Smash staff and I are located right here in the Lehigh Valley. So here's the way that's expected to play out. Again, that's 6 Universal Time on Sunday, so that would be 1 a.m. That's 1 a.m. and here would be 6 a.m. Eastern, rather 7 a.m. Eastern Time here. And we'll also show you the Euro forecast for that same time. And there's where the Euro forecast is calling for things to be at 8 a.m. A little bit lighter snow there, but yeah, a foot of snow forecasted in that area of southwestern Texas. Let's see if Greenland's melted yet. Oh my God, Greenland is melting. Holy cripes, son of a beehive. There's only 185 inches of snow there. And check it out. This is the ocean right here, folks. That's not even on the land. And there's 178 inches of snow there on the southern tip, which is exposed to the Gulf Stream, I might add. Oh my God, it must be so hot that it's cold. Let's move on to look at the cloud layer over the U.S. It's another value-added service here at the Smash News Network. Least busted name in news. Man, I'm seeing like a like an overall clockwise rotation happening here, as we see a bunch of low clouds over the Atlantic and indeed the Gulf of Mexico, but mainly these. These are all low clouds right here. And by the way, low clouds are associated with cosmic ray flux. They make for colder days and warmer nights due to the greenhouse effect. Yeah, I said it. The greenhouse effect. The greenhouse effect is real, especially when it comes to water vapor. Yes, water vapor, Earth's primary greenhouse gas. As clouds reflect infrared radiation back into space, they also cause the ground to stay heated up at nighttime. Yes, low clouds make for colder days and warmer nights, folks. Anyway, here's the water vapor map. And you can see this system is stagnating down here. Just hanging out, as that dry mass of air is not really moving. And for you non-meteorology nerds, dry mass of air, like this area here, tends to be colder and is certainly more massive than this moist air. And that all has to do with the molecular mass of atmospheric nitrogen versus atmospheric water. Dihydrogen oxide. Yes, it's the dihydrogen oxide and the atmospheric nitrogen that are at play there. And that's confining all that moisture into this tight area. So not all that cold. And again, here's the cloud layer. And we'll actually zoom in on the water vapor area here for Western Texas. Shout out to our Texan viewers. And you can send us photographs, post things at smashomash.com/forum if you like. We may feature it on the Daily Space Weather, especially if you have record-breaking historic snowfall. So that's what's going on there, and that's the cause of the stagnation. If you look at the Doppler radar and it's not helping, just look at the water vapor map. This is the NASA GOES Interactive Weather Satellite Suite. And what's good about this is that unlike ground-based Doppler radar systems, which are measuring movement in the air column, the water vapor satellite is measuring all of the water vapor, include that which is not condensed onto clouds and that which has nothing to do with precipitation. Check it out, we've got dry air rotating counterclockwise. And it all has to do with that low interacting with that dry mass of air. And we've got value-added features. It's the bonus features. Don't be a boner. View our features. And don't try to sell us subscribers, or you will get timed out. I consider that spam. We don't pay for subscribers. We get paid to have subscribers. So we're going to show you the colorized magnetogram here and the solar intensitygram to show you the latest high-res images of the local yellow dwarf. There's the colorized magnetogram. Here's sunspot 2794, and there's sunspot 2795. This umbra here has not degraded that much, and again, there's a whole bunch of filamentary material in between the Earth and the Sun right now. No other sunspots that I'm aware of. Let's see. Indeed not. There's a close-up of sunspot 2794 and 95. 94 has degraded a little bit, as we see a light bridge right there. And 95 is actually fairly steady here. So there is still significant possibility for solar flares, but especially coronal mass ejections. And let's do some close-ups, as we've got some great views here of the Southern Hemisphere at the Smash News Network, least busted name in news. So there you go. There's 171 angstroms in the Southern Hemisphere, and you can see a whole bunch of activity in the trailing region there, the region behind sunspot 2795. And that's where I wouldn't be surprised to see a coronal mass ejection emanate from. Also some interesting filamentary behavior on the left of your screen there. The southeastern limb. Here's the same area, and you can see the filaments a little bit better here. A whole lot of filaments in that region. I won't draw them in. They're pretty obvious in this wavelength, 304 angstroms. Let that play through a second time here. And here's the magnetogram of both of those sunspots. Anyway, thanks for tuning in to our last episode of the Daily Space Weather. We'll see you never. And may that solar wind be at your back. And that demonic sandwich being cooked on your stove or grill or perhaps in your oven.